Good morning all. I welcome you all to know about the great coaching class, and today I am just going to focus on computer networks, and particularly we are going to focus on IP addressing and subnetting. Myself S.A.ENGG.COLLEGE, Associate Professor, IT Department, and here I am just want to have a computer networks details of the syllabus that covered in GATE classes. So as you know that it was syllabus covered in the section 10, and these are all the contents that displayed for computer networks, and today I am going to particularly insist about IP addressing, CIDR notations and subnetting. That covers all the details regarding the IP addressing. And as you know that when we have a IP addressing, it was generally a network layer, and that network layer covers the content of IP addresses and that focus on each and individual's connections of the computers. So when we have a IP address, it is the only communication way that all the scenarios of networks is getting connected, and that was associated with the subnetting, next to CIDR, and we have a IP version 6. Nowadays we are following IPv6. And now when we have these kind of IP addressing, it handles the end-to-end connection. So the primary devices that connect with the internet world, that was highly associated with the IP addressing, and the most commonly, it was a most commonly used network layer protocol, and that handles the all traffic distortion in the networks. When talk about these IP addresses, you may have a discussion over that how we are making use of those IP addresses. So our GATE coaching is now focused on those content, and apart from those GATE syllabus, out of 42 credits of core computer subjects, 7 to 8 questions is coming from this computer networks. That's why I'm just going to concentrate on those things. And this is our agenda. So when we have a discussion on IP address, the primary content we should know is how it is getting an interface with the network, and how it is routed, and then how it handles the different identification notifications. So these are all the main impact of computer networks, and particularly on IP addresses. And the special intro part of IP addresses, it was a 32-bit long identifier. So whenever IP address is going to connect with any organization or any number of host to host or organization to organization, that was only thing is they have only a 32-bit long identifier, and it encodes the network number, and that has two divisions. One thing is host number and another is a network prefix. So here I am going to give you a brief discussion about how we are handling this 32-bit long identifier, and how we are focusing on this network prefix and host numbers. And this is a default structure of a IP address. So when we talk about these 32-bit long, they are 4 divisions that have a 8 part. So first 8 bits. So first 8 bits, second, third and fourth. So the first, each byte is identified as a decimal number. As you know that when we are having IP addresses, as a user, we know only the decimal number that enclosed here. But in the way of IP addresses, it was a decimal, it was a binary bits, and it was enclosed in this system like here. So first byte is referenced 128, and second byte is 143, third byte 137, and fourth byte 144. So these are combined, and we have IP addresses of 128.143.137.144. So here it has a default value from 0 to 255. So any number that has it starts with 128 here, but actually it can encompass 0 to 255 range of numbers. This is a default IP notation, and here the first 2 subdivisions of 8 bits can be combined as a network prefix, and second 16 bits will be the host number. So whenever we are fixing the host number in different organization, it just focus on the host number. You know the value of host number, but many of us not concentrate on network prefix. But for the IP addresses, network prefix is the major concern and it should be properly aligned for each and every organization. Say for example, if you are a small network of a college or institutes, the network prefix should be properly aligned with the network protocols. So here first it was interfaced with the network prefix. Then secondly, we can have an implicit version of network prefix. There is a net mask. First we have to define the net mask, then each and every organization will go with the network prefix. See, this is a best example for explaining how the network ID, host number and network mask to be fixed. Say for example, the first one what I have given here is an example of an organization that was associated with the education. So here ellington.cs.virginia.edu. So this is the actual URL that we focus. So when we are typing the URL, the HTTP shows the content of this alone. But inside it we have a IP address notations that the Virginia University will fix that 128.143 and each and every host they can have their own network ID. Say for example, here the first two subdivisions of 8 bits is controlled like 128.143.0.0 and second the host number that was associated with 137.144. Similarly, each system in the Virginia education system can have 137.145 then 146. So these are the host IDs. Next, we prefer network mask because here the first two subdivisions are 8 bits and 8 bits. So here we have to explain that how the network mask is described. So here 255.255.00. So this is the enhanced version of network masks that are associated only with Virginia University. So here it can be a hexadecimal also. That description also I have given. So here this is the main part. So this is the network prefix and it can be from 0 to 255. 0 to 255. So here I am giving 128.143. So up to the limit of 255 they can fix the network mask. And this is the prefix notation, and here the 16 represents the network prefix that they are can be able to fix up to 2 to the power 16 IP addresses for their organization. This is the real concept of IP address and network prefix. Hope you understand. Next, we can go for further examples. Say for example, I mentioned that it was a 32-bit binary number. So here just we have a full of binary digits where 4 8-bit octets are enclosed. So when we have these kind, we can convert that into a decimal part. Then after that we can fix them as a subnet. So the main part of a subnet is without any network prefix we can physically reach their destination. So there are clumsy of organizations that holds more than 1000 or 5000 or 2000 organization computer system can be enclosed. So in that position they can go for the subnet where physically each other can contact without any intervention around them. So this is the main concept of subnet. In further description I will explain you what is the real nature of subnet. And this is what the Internet IP address protocol header format. So you know that it was a 32-bit long, and here each is a binary and next is the dotted decimal. So always it is possessing the dotted decimal notation. Every organization should have a dotted, even if they converted that into a decimal or any word of the URL that can be enclosed. That's why we got www.google.com. So that is a dotted notation that has a split up and each one has their own specifications. And here the fundamental divisions of these bits will be explained through the network ID, host ID and the telephone, like a telephone number. Say for example, without the network ID we cannot go for the host ID. With the default value of network ID we can have a further clarifications of host ID. So here the main part is the first two 8 bits scenario, then we go with the 157 and 177. Next. This is the format of a header that associated with the IP addressing protocol. So you know that there is a network layer where each and every layer transfer the data from one protocol to another protocol. Another layer will have a comparison with the other protocol, then they have the extractions of data. This is what we learned in OSI reference model. So each layer has its own functionality. Similarly, network layer has a IP address where they hold different notations and they have the entire data to be encompassed. So here I just want to give you details of these things, what can be handled through the IP address. Say for example, this is the entire 32 bits where every bits can have their own functionality. The first 4 bits is for version, that is if you are using IPv4 then it will be defined as IPv4. If it is going to be IPv6 then it can be IPv6 in this particular 4 bits. And then we have to explain what is the header length. Then we have a types of service. So which type of service the data has to be handled, and it can be driven to the other protocol. All these informations will be enclosed here. Then the total length. So if it is going to be a 82 bits or 32 bits length, then it should be mentioned how long the length will be enclosed here. Then we have identifications and we have a flags that presents the offset of either zeros and ones, and then we have a fragment offset. After that we have a protocols and how long it will be stay back in the organization and the header checksum. So all these controls is given through the split up of 4, 8, 16 bits when the conclusion of 32 bits enclosed. And here the source IP address is 32 bit and destination IP address is 32 bit. So obviously the transferring of data from one system to another system, that will be given through the 32 bit address. That's why here mentioned source IP and destination IP. And this is our IP header. This is where the network layer will connected and Ethernet header and Ethernet trailer. Within this platform the IP header will be placed. And this is what IP addressing the full form. So whenever we have a classes, the class mentioned about these dotted decimal. So when network is associated with host, then actually it predicts the full form of IP addresses. And this is what an example how they are divided. For example, I mentioned the first example I have given network host, and here maximum the limit is 255, and similarly for host it also be a 255. Again for the binary and for the other digits, here I have given the descriptions how it is transformed to a decimal digits. Say here if I am taking the first one, if we move on to this, the first 8 bits have the control of 255. So here all the digits will be 1, and from this point we can mention how long it will be the decimal digits. So it can be 1, 2, 4 and then 8, 16. Similarly for this digits, this 124, 128 up to 128 we can accept because we have a network mask of 255. Again for this 255 we have the same scenario, and we have the control of this 128 up to 128, and that can be accepted to 255. So this is what the destinations of 0 to 255 will be explained. So the total IP addressings will be relayed like this. So we can have a binary, we can have a decimal, we can have a wording format for the URL, but the major process is done through the bitwise format. That's why always it will be represented as a 32-bit binary address, not with any form of decimal or content related. It is only focused on 32-bit address. And this is an example where I just explained in the previous slide. I explained how this 255 is enclosed with a binary digits, and now if you present 172.16.122.204, how it will be transformed through the binary. So this is an example. So here for the 8 bits digital notations, we have to explain all those things. So this is another example. and this is a major concern of IP addressing. So totally the IP addressing is focus and concentrate on classes, defining the classes. So whenever we have a class of A, B, C, D, these are the multi versions of IP address, and we are now going to have a descriptions how these are helpful in building the IP addresses. Say for first class A, you have to remember that it is having only the network ID of 8 bits. So remaining those 3 8 bits will be hosted for the big organization. So if I am having a larger organization, I can go for the class A, where I can fix a network as a one scenario, one 8 bit, and later on I can fix for all the hosts that are associated in my organization. So a smaller unit of organization never required such kind of class A, but class A is for a big organization where numerous systems are entered as a hub, and they have so many blocks of organizations, blocks of systems. All these can be enclosed through the class A. But for the class B, if you are focusing on the very smaller unit of organization or within a normal infrastructure or with the intranet, we can go for the class B. And class C is similar to that pattern of very smaller unit of organization. Where class D is for a multicast version, whereas class E is reserved for research area. So these are the very fundamental things that IP addresses, and as a learner you should know how these classes are defined in the IP addressing. Since gate entrance exam will have so many part involved with these classes, you should more concentrate on these kind of classes. So here I am just giving you the description where the network and the host ID is focused. Say for example, the first class A, I mentioned that the range is from 0 to 255, and it was having 8 bits. So here we defined 1 to 0 to 126, and then 127 to 128 to 191 is for class B, and then 192 to 223 is for class C, and later on 224 to 239 is for class D. So here for the each and every organization, if I am fixing a larger organization, I just want to have a 1 to 127. So if I am going for the 128, definitely it will focus on the class B addressing. So whenever you want class A, then definitely the network mask should be from 1 to 127. And similarly, you can see the variations from the 32 bits 1 to 32, how each and every classes are defined. All these things will be controlled. Say for example, taken class C, we have 192 to 223. So these will be encompassed here, network and network. So 3 8 bits will be controlled with these 192 to 223. If you are focused on 224, then immediately it ranges from class D. And this is the major descriptions of class A to class E. So here I mentioned in which category these classes are encompassed. First one, the class A is for the 8 bits, that is a network mask ID, and 24 is for host ID. And majorly they concern with the description of for the very large organization with hundreds of thousands or even millions of IP addresses that connect to the internet. So obviously for the major organization and like Google servers and other kind of applications, they majorly focus on these kind of class A. Then for class B, I told you that network ID will be first 2 bits of 8 bits, and then second 2 bits of 8 bits. So this is 16 and 16. And the major organizations that have a medium of hundreds to 200, they can have an enclosure of class B addressing. Then for class C, we have a unicast addressing for smaller organization that with 250 hosts. So this is a major structure unit of class C, where we need 250 hosts that can be given with 8. So now you are able to understand that network mask will be 24, but for within 8 host ID, I can give 250 or 250 kind of host ID with this 8 mask ID. So this is what next. Class D is of a multicasting. So wherever you want extension of your work of the IP address, in that position the class D will be described. Class E is for the research purpose, where any part of a research oriented multi-cloud or any kind of cloud deployments, other things that can have a encompass of class E. and this is the structural unit of network ID and mask ID. So first, just wait for the interfaces. So this is our interfaces, that is, it is a hub unit where these interfaces are getting connected, and these are the hosts that individually componented with these routers. So E0 and E1 here placed a role of interfaces, and where different components are getting connected. So when we placing the IP address, this major part of 172.16 will be the first whole part. So within that 172.16, I can fix the IP addresses for this batches and for this batches. Say for example, in this batch, the first part of E0 is an interface that with 172.16. So here I am making 172.16 and then again 172.16 and 172.16 with the three interfaces, and I am placing the number as 2.1, 3.10 and 12.12. So these host ID, since it was of class B, the variation will be with these two things, last two, host ID. So here 2.1, 3.10 and 12.12. So these ID will be the reflection of all other things. So here the network ID, then host ID. This is of class B address. So here in this part, for the second batch, 172.10.0.0 is the interfaces of E1, and this E1 will be given here. This three part will be encompassed with 10.1 and 10.250, 10.180. Now you can able to understand the difference of class B and class A. Here it was a class A type because the first 8 bits will be the full control of network ID. So after that I am fixing all the host ID to be a different one. So here it was a class A, and this interfaces mainly focus on class A address. This is the example part of implementation level in the organization. So if you are developing a network as a network administrator, they will first fix the interfaces and the peripheral components, then later on they will fix the IP addresses for them. So based on that, the peripherals and other classes will be defined. And this is what the full isolated networks getting connected individually. Totally it was an individual component, but as a network, the network will always focus on the connectivity so that the data can be transferred from one component to another component. So if you are having a host of different area, that means the isolated networks, they can be controlled as one from the one router. So in this example, I given you R1, here it's R2, and here it is R3. So these are the routers where each and every components are getting connected. So when in the internet, when you are transferring the data, the computer will recognize only through the IP address, and that too from the routers. So the router major job will host the computers and identify which network it was requested. So from one component, if I am requesting, say for example, if I am giving www.amazon.com from one peripheral like 223, take an example, 223 1.9.1. So here I am just going to give you the request of URL www.amazon.com, but the URL went out, the server reaches, then the response will come. How they are identified that the particular computer like 223.1.9.1 is requesting that URL. So this is the major task that was allied with the internet world. So here the major job is done through the routers, and router plays a role of controlling all the networks, and they have the routing table. That router path will decide which is the source and which is the destination. So here we have given these networks where the 6 networks are getting joined and allied with R1, R2 and R3. So when we don't want any kind of networks like this, we can easily detach. But one with the IP addresses always give the details with the routing table. So once it get attached with the network, definitely it was controlled by the router, and router keep tracks of all the details that will along with that IP address. This is the major concern of network ID. The IP addressing, and here I am just giving you the class full addressing. There is a two part in IP addressing, class full and classless. So far I have explained you about the class full, that is from class A to class D, and here we have shown the full computers based IP addresses. Say for example, this is the first one I mentioned previously, network with 3 part of other subdivisions of host ID, and class B is for network 2's 8 bits of network and 2 8 bits of host, and again third 3 parts of network, and the last remaining part is host, and these are the full controlled versions of class. That's why it is named as classful addressing. So here the 4th and 5th will show that all these among 32 bits, it will start with this level. So you can understand how these are given in the say this is 1 to 127. Definitely it should be 1 to 127, and in second category of class B it is 128 to 191. So this is what the highlighter of a class B, and class C 190 to 223, and later on class D 224 to 239. Till this IP addresses it will be allowed, and we don't have other options of multicasting. If you go for the multicasting and other reserved area, definitely it should be a class E purpose. So here the interfaces, how long we can fix the interfaces. This is the major unit of IP addressing. So till class D I just given you the informations. So first, this is an in-depth knowledge of IP address, how it can be controlled by the interfaces. Say for example, 2 to the power 7 networks can be given with the class A, and 2 to the power 24 interfaces can be given. Say in previous slides I explained you E0 and E1 where I have shown 2 interfaces. Similarly for class A we can have 2 to the power of 24 interfaces in the network. So as you can imagine how the I told you that it was for large organization. So for large organization there were numerous, even they mentioned about millions of computer. So millions of computer can have the interfaces of up to 2 to the power 24. So the interfaces increases, definitely the host will be increases, and the host increases, the network will be increases. So they are the dependent part. And for the class B, as you mentioned, as we have a knowledge of 2 8 bits, so the networks how they can encompass is 2 to the power 14, and interfaces level is 2 to the power 16. And similarly for class C, the 3 is the network, so similarly it was increasing. So 2 to the power 21 network we can have, and with the host of 2 to the power 8 interfaces. So as you know that when network got increases, interfaces got decreases, because when the allied networks have combinations of all these networks, there is no chance of having host to be increased. So that's why the interface is getting decreased when the networks getting increased. So you can understand the patterns of network and interfaces. Next we have go for the full description of classful addressing. So when an organization supports these kind of level of notations, the IP addresses is fully focused on these kind of things. Say for example, class C network can accommodate 2 to the power 8 minus 2, that is 254 hosts in their organization. So that's for class C. This 2 is for reserved. The reserved category is for mainly for multi-objective sharing model or multi-objective multicasting model. And then later on we have a class B where 65,634 hosts can be maintained, where it was too large for the organization. Say here 2000 hosts ended with this class D address itself. So addressing income when getting increased, the class B is limited with the sources. So even though it is capable of doing 65,534, the limited source acceptable for making class B is 2000. We can have more than that also, but organization simply have a class B, then they have even have the 2000. But for the class A it was limitless, and we have more than these kind of classes. So later on for these classful addressing, they specified with the limitations. So they divide the whole IP addresses into a new format that is called CIDR, that was introduced in the year 1993, and it was a classless interdomain routing. So when a dependent of classful addressing, we always have a IP addresses with the class A to class D reserved and for the reserved category. But this is not a possible thing for many organizations where trillions of computers getting connected. So at that time, classful addressing is not going to be capable of doing that. So they come to the point of CIDR, where it is meant to be classless inter-domain routing. Your GATE syllabus will cover CIDR also, because up to 7 to 8 questions having the syllabus from the IP addressing with the whole networks. Class CIDR also expecting the questions from those syllabus. That's why I am covering CIDR. And this is an example how we can have the conversion of binary to decimal. So here it's a combination of 172, 16, 00. So as you mentioned that it was a host, and this is of class B. As you know that first 2 bits is for class B. Next, here this 172 we have a decimal notation, binary, and 16 is also having a binary notation. But I told you that the class B is capable of compassing 65,534. So this is the description how it is going to control all this host. So the 2 is for, this 2 is specified for reserved category. So 2 to the power n is our target address. So 2 to the power 16 minus 2, that's giving 65,534 hosts. So this is for entire class B addressing. And this is an best solutions for finding which will be the IP addresses, which will be our host, and which will be the class address. So here I narrated some of the examples. Say for example 10.2.1. Similarly, I have given so many IP addresses, and let me check how far you have learned these classes, network and host. Let me have the solution. See, for these examples, these are the solutions. So as you know that 10 starts with a 1 to 171, we can reach 127, we can reach with the class A. So this is the class A, and this is our network. Since it was a, we have a network with the 8 bits. So 10.0.0. Then other things are host ID. Similarly for the pattern second one, 128.63.2.100. The example, it was a class B. Then later on it has a 128.63.0.0. This was a network, and mask ID host will be 2.100. And later on we have a 201. This is the third example, and fourth and fifth. Similarly we have all the IP addresses and their corresponding network and host. Let you also try for such kind of IP addresses and with their network and mask, because GATE always focus on having these kind of network area, network and host area. So when you try for computer network subject, you please be concentrate on these both categories. And this is the classful addressings and their descriptions, how they are giving the control over the network. Say first, it was a flexible, but the lack of internet address is also a flexible one, because when we reach the host, the router have the full responsible of routing through the routing table. It carries the responsible of handling the IP addresses. The internet world getting struggle for reaching those routers and those IP addresses. This is not in the flexible format. So the classful, when we go for the IP addresses, this monolithic nature of big organization completely gets the control, and there is a struggle of reaching the IP address. This is the very first common issues in IP addressing with the classful nature. Second, there is an insufficient use of address space. Even though the network and host, all those things almost covers all the IP addresses, since there are more number of requesting for the client and user requests, there is a shortage of IP addresses. So here the address space with a limited storage of classful will enhance with more complications. So this is a major drawback. This is the second major drawback. And third, we have a router table entry. So always the router should keep on track of router table. So router table always should be an active one, and if in case of any failures, the entire routing table will get eradicates, and so that the network get eradicates. So the routing table should be always focused on having active entries and duplications of all kind of sort of routers informations. These are the three major concerns that has the limitations of classful addressing. Next we have a subnetting concept. When we have IP addressing, there should be a possibility of having subnetting. Here the major definitions for having subnetting is it will prevents your network ID to be a masked one. Say for example, if I am having a university, that university has the 3 organizations and they can have a engineering, they can have a medical and they can have a library as a separate unit. So when we have these 3 part of a unit, definitely there should be a networks with 3 concern and each and every IP addresses should be placed different way. So this subnetting will now provide you to have a subdivisions. So the entire IP addressing is the one part and second the subnetting will be holds at the second part. So when the solution is giving a further improvement, then definitely IP addresses will always be a successful when we hold that with the subnetting. That's why I am giving the definition. It is of focusing adding another level of hierarchy to the IP addressing structure. So obviously when we have a subnetting mask, definitely IP addresses will be the strong nature in the network routing table. So allocating more number of IP addresses, we need to have a subnetting that can be very enhanced version. So the subnetting always preferable for the IP addressing. So here what the nature of subnetting will do. Here the network prefix and host number. So far we have seen these kind of IP addressing format. Now the subnetting will do with the further divisions. So this host number is now protected with the subnet number. So here it is again splitted into 2 versions and that extended network will be always stagnant with this subnet number. So because of subnet we can have a mask for our IP address so that the outside world doesn't know how the router table is getting organized. So this is a major security concern that subnetting is a major play a vital role in preventing or providing building of IP addresses. So this is a freely assigned one. So when we fixing IP addresses, it was again the freely assigned with an organization and again the subnetting treated as a separate network. So impact of subnetting gives more concentration on IP addressing. So definitely it will become a successful one. And this is also a 3-layer hierarchy. So when we have a network, then again we can include the subnet and again we can go for the host. So it has the improved efficiency of IP address and the entire addresses will have the router complexity. All these things will be getting reduced. Say here reduces router complexity. So when we go for the subnetting, obviously the subnet will protects your router table and it always getting updated. So we are not going to concentrate on router table. The subnetting take care of it. So the subnetting is a very important role played in the IP addressing. And length of the subnet mask need not to be an identical one. So we can fix any kind of subnetting, any numbering concept can be applied in the IP addressing. And this is the key goal of CIDR. So when it comes to the subnetting, the next part of the IP addressing is a classless interdomain routing. So as I mentioned that router table becomes a complexity in building and updating, keep on updating and keep on tracking. The major concerns are reduced through the CIDR. So it was the main goal of CIDR is to restructure the IP address assigned to the router table. So there will be the hierarchical routing. So instead of focusing on one router table, there will be the hierarchy and that is the clustering where all the routing table will be controlled from the CIDR. So instead of making use of a direct routing table, we can closely watch with the CIDR, then we can focus for the classless routing. So here the key concept is it was always arbitrary that length of the network will be always addressed with the proper channel. And then the consequences, if you are using CIDR, then routers can advise with the IP addresses. So the IP addresses major concern and monitoring will be taken care of CIDR. Through the routing table, we can majorly target with the IP addresses and that was controlled through the CIDR. That is the major issues. And here CIDR, if you are using CIDR, the major concern with the network addresses, it will given like a /18. This specifies that the first 18 bits are the network part of the address and remaining 14 bits is for concern of host address. This is what the CIDR will fix. So instead of going for the class A, class B, class C, I am just mentioning /18 or /16 or /32/4. Likewise, we can split up the entire domains, and here we can explain that with a prefix nature, that is mentioned like a slash. And then this CIDR will assign with a continuous block of 1024 addresses. So 1024 with a 22 block size. Here we mentioned 18 block. Similarly, 22 block size can be fixed through the CIDR. And this is an example. So when we have organizations with a humorous host, I can fix that with a slash. So increasing in block, increasing in host. Say for example, if I am having 13 blocks, each one can carry 1024, and we can have 5,24,288 hosts encompassed with this. Similarly, for each and every block, there will be a separate host address. We can fix these many kinds of host address when we are using the CIDR concept. And this is the very backbone of the IP addresses, because when I am fixing the block will take care of the router table, and we no need to concentrate on which part of the classes. Instead of going to the important nature of classes, we are now going to concentrate on the blocks. So each and every block will take care of the routers, and they will segregate the IP addresses, so that when internet comes to the point of reaching www.amazon.com to the particular IP, instead of going to the router table, the subnetting and the CIDR will now take a responsible. So here this 522 block will encompass with the 512 nodes, where 2 to the power 9 less than or equal to 2010 2 to the power 10 levels of IP addresses can be concluded with this block size. And this is what the CIDR will do with the IP subnetting. So here when we have a 32-bit, the first 24 will be given for the fewer subnets, and next part host ID will come with the subnets. Say for example, the first will be 2 subnets, 4, 8, 16 and 32. So similarly, for each subnet I can have more number of hosts. So this is the greater advantages when we go with the subnetting part. And this is with a huge knowledge of in-depth nature. There will be a high advantages. Say here I am grouping. The first one is, first part of the advantages, we can grouping, and we can make use of a dotted decimal notation, and we have a 4 billion combinations, and we are encompassing that with 3 sizes: class A, class B and class C. These are the very important knowledge that every gate coacher has to understand. Then these are the sample example for class A addresses, that is limited with the ISP. Say for example, Google and CNN, WB, all these channels on every site's large internet connections will always closer to have a high attached class A addresses, because they need multi-purpose purposes works, and they need more number of IP addresses to work on it. So they will use majorly, they depends on the class A addresses. And later part of class B will be for the smaller organizations, and they can have a two octets of divisions. So here some of the class B addresses can be given for similar patterns of organizations. And this is for class C, where 250 hosts can be controlled, and they are distributed via the internet addresses. And this is for the reserved address. Class D is for reserved addresses, and they are majorly for the private networks that given for the each and every individual components in the home system or PCs or desktops or tab, anything. We can have IP addresses for these kind of reserved category. And this is net mask. So net mask, we can have a net mask of host with a class C. So here I can give a net mask with the help of subnetting, and so that each and every host can be encompassed with the other level of determined part of IP addresses. And this is for addressing without subnet. I am just given you the clarity of using a picture. So this is addressing without subnet. So actually we can mean for the networks totally controlled with a one single router, and with a network 772.16.0.0. And now this is with subnetting. So when I make use of subnetting, I can go for various levels and they are controlled with the interfaces, so that the network is fully have a controlled from the subnetting instead of going for the router table. And this is a subnetting addressing. So here we, instead of E0, E1, the previous diagram, we understand E0 and E1, and again these interfaces is now given with the part of 172.16 dot again 12 with this part. This is a process of subnetting. And this is the variation that each block can control. Say for example, I am giving a default subnet mask, and for class A, class B, class C, we can provide with the blocks, and each one represents through the ones and zeros. And this is the part of explanations how we are having the control of each binary digits. So this is from 1 to 128, and each and every divisions how they are defined. So these are the binary to decimal conversions. These are the patterns, and with the explanations of each and every questions, I am just giving you the clarity how the gate will expect the learners to give such kind of multi-objective questions. And majorly they have 7 to 8 questions for the class B and other IP addressing, and total computer networks will focus on 7 to 8 questions from the gate exams. And here just go with the first question. In IPv4 addressing format, the number of networks allowed under class C addresses. So what will be the answer? As you know that I mentioned each and every category of class A, class B, class C, and here they given class C. So the answer is 2 to the power 21. So 2 to the power 21 IP addresses can be hosted through the class C addressing. And this is because the 8 bits are reserved for the host ID. So this is the explanation, and 24 bits reserved for the network ID. So apart from that 24, out of these 24 network ID, the leading 3 bits are fixed as 110. So remaining 21 can be enclosed as a IP address. That's why we go for the 2 to the power 21. So these are the expected questions regarding addressing formats. Second question. On a local subnet with a 255.224.0 subnet mark, what is the maximum number of IP address that can be issued to the host? So out of these they have given the numbers. So we have to derive how many hosts can be enclosed with the format of class B address. So the answer is 8190. And the explanation is, if we are having 255.255 from the class B addressing, and we have a 224 with the binary digits conversion here, the third octet has 224. So 224 means 3 consecutive ones. This is 3 consecutive ones. So the number of zeros is 13. Among this, the total number of zeros is 13. So the maximum number of IP addresses that controlled is 2 to the power 13 minus 2, which is 8190. Hope you understand how you can have the conversion of the class B addresses to a network ID. Okay. So you have to count the number of zeros, then 2 to the power the number of zeros. Again the answer will be from the minus 2. And third question. Given IP address belongs to class C. So they have given an example of class C. Then here how they are derived. For example, default mask. They will give default mask 192.0446. So from this we have to identify which class it belongs to. So as you know that the IP address starts from 192. Obviously it was a class C, and they have given us a mask. So again we have to give the complete structure of this. The objective will be have these kind of examples also. Then fourth question, suppose that instead of using 16 bits for network part of for a class B address, 20 bits have been used. And how many class B networks would have been possible? So out of 16, they have provided 20 bits. So now how the possibility of having IP addresses? So the solution is total 20 bits used for network ID of class B, and the first 2 bits are always set to 10. Again then with 18 bits, number of network possible is 2 to the power 18. So in this scenario, you have to identify the number of settings to closer to the 2 bits, and finally find out 2 to the power the number of bits. The fifth question. Suppose an organization wants 6 subnets and each subnet has at least 22 hosts. What subnet mask should the organization use to fulfill the above condition? So here they given the number of subnet and with the host 22. So as I mentioned, CIDR presents the block size of 22. So now we can have the solution for this. The answer is 255.255, 255.224. That is the second answer, and we have the solution for this. So when we have a derivation of 20 bits, 6 subnets they have given, and then 3 bits required for that. So 2 to the power 3 is 8, and they have given the block of 30. So 2 to the power, here the remaining bits in the last octet is 5. So 2 to the power 5 minus 2, we can set a host of 30. Again, we have a octet only within the 22 host we should present 30. So it's possible only we have these kind of network masks. So out of this we have to enhance 30. 22 hosts they already mentioned, but we have derived 30. So the subnet mask always to be fixed is 255.224. In this situation, this 224 will allow you to have a 30 subnet mask. So this is the solution. So in this, try to have these kind of solutions when we deal with the IP addressing, CIDR and subnetting, and it will be very efficient if you deal with the IP addresses and always have the full closure of computer networks. Thank you. Thank you, students.